Economic growth. So far we talked about the short-run fluctuations. Now we're moving on to the long run. So economic growth can be defined as sustained long-run increases in real GDP. It's not about short-run fluctuations of actual GDP, but about the growth of potential GDP in long run. Okay, so we're not talking about the actual anymore so much, but more about our ability, our potential. This is the same as the PPC, by the way. It's our production capacity. The short-run fluctuations in economics are called business cycle. So business cycle are the ups and downs in the short run, but the long-run trend is called growth. What that means is higher income, higher national income, and higher standard of living. Okay, so that means more comfort, more consumption of goods and services. The cost of growth is less consumption today. So we have to reduce our consumption today so that we can save more, and that saving is going to be converted to investment. So it's going to be lent out to the investors, and that is going to give us more goods and services to consume tomorrow. The social cost of growth is that some skills and machinery become obsolete. So you get some level of unemployment, but that is only a short-run problem. Okay. So growth, where does growth come from? It's really a result of investment in capital. So if you remember our four resources, one of them was capital, and capital had two main types, physical capital and human capital. Both of them are quite important, and both of them are the source of growth. They result in higher productivity, and productivity, this is a common mistake by students, so you might want to watch out here. Productivity is an important term. Productivity is not the same as production. Production is GDP. Productivity is a rate. Okay, it's output per unit of input. Think of it as the speed of production. That's what we mean by productivity. So pause here and write down. So let's talk a little bit more in detail about the sources of economic growth. We're going to talk about four main sources. One of them is simply the labor force. So you can think of it as if you have more population. So that would be the hours put in production. That could increase our GDP. The other one is human capital, which is the skills or capabilities of workers. So examples are education, training, and health, where you can basically multitask or you can do things faster. Okay, basically human capital is the quality of the workers, whereas labor is the quantity of the work. So the hours of the work, regardless of how skilled they are, that would be labor. The level of skills would be human capital. A third cause would be physical capital, such as plant and equipment. So electrical machinery, transportation, communications. And these are due to positive net investment by firms. So that I in the AE formula, if you remember, that's an important element when it comes to capital and growth. And we have technology, and technology, you can think of it as a knowledge of how to make use of our resources. Okay, so engineering, management, scientific formulas, new designs, so knowledge basically. And that's due to innovation. So new ways of production, organization, and management. So write these down. There is this famous neoclassical growth theory where GDP is expressed as a function of the resources employed in the production of goods and services. So we have this thing called the production function, which looks like this, right? This is a simple functional notation. What it says is that GDP is a function of these three things, L, K, and H, and we're going to talk about what these things are, and the T stands for technology. This is a simple functional notation where L is labor, K is physical capital, like machinery and equipment, H is human capital, which is the quality of your workers, you know how much brain they have, and T is technology, which is implicit in the model. Okay, so that in technology is really not a resource, but a form of knowledge. It's the how-to. It's how to make use of the resources. That's why it's part of the function, not really a resource. We also had land. If you remember, one of the resources is land, which includes all natural resources, but those are excluded for simplicity in this model. Okay, so what the production function really says is that our GDP depends on the level of these resources that we have based on the technology or our knowledge of using them. There are two useful laws that govern the production function. One of them is called the law of diminishing marginal returns. If we start adding more and more of one input, GDP will increase at a diminishing rate. So for instance, the employment of each new worker adds less to total output than the previous worker did. The second law says that it is called the law of constant returns to scale. If all inputs increase by X%, GDP will also increase by X%. Okay, so for instance, if you increase all of the inputs by 20% in a, let's say you have an ice cream factory, or an ice cream shop, your output is going to increase by 20%. If you have taken microeconomics, you should have heard of something similar to these two laws. So they are kind of universal. One thing to clarify is in the first law doesn't say that GDP is going to fall. GDP doesn't fall. GDP increases, but it increases at a slower pace. Okay, so the increase in GDP is going to level off, but it doesn't actually fall. Another thing to clarify here is that the first law is about one input only. The second law is about all inputs. Okay, so the picture here needs some correction. The picture is not about 20% increase only in labor. It's 20% increase in everything: labor, raw material, capital, electricity, all of the inputs that you have. If all of the inputs increase by 20%, then your ice cream is going to increase by 20%. Pause here and write down your notes. So let's go back to our sources of economic growth and see how they work with the two laws that we have. If the labor force goes up, GDP is going to go up, but at a diminishing rate. That's because of the first law, the law of diminishing returns. So for instance, if there is an increase in population, we want to see what happens to our standard of living. And the standard of living is really our GDP per capita. So GDP per capita, you've heard of it before, it's GDP per population or per person, right? So you take GDP, you divide it by the population, you get GDP per capita. Very simple formula. Now in this scenario, what you have is population is increasing, GDP is also increasing, but population is increasing faster than GDP because of the diminishing rates, which means your GDP per capita is going to decrease. So if you have a situation like this, the standard of living is actually going to decrease. All right, so the change in population is greater than the change in GDP per capita, standard of living is going to go down. Now, another option is let's not fuel our growth by labor, but let's fuel our growth with physical and human capital. Again, GDP is going to increase, but at a diminishing rate. And assuming, so this is again the law of the first law of diminishing returns, and assuming that we have the same population, ceteris paribus, remember ceteris paribus, it's all other things being equal. If you don't remember that assumption, write it down. Ceteris paribus means all other things being equal. So we have physical and human capital going up, but population is the same as before. So our GDP per capita is going to increase, but at a diminishing rate. Okay, our population is the same, our GDP is going up, but our GDP is going to increase gradually, and gradually is going to slow down. Now, what if all resources go up? Capital, land, labor, whatever. If they all go up, then GDP is going to go up at the same rate. And that was the second law, the law of constant returns. So if all of the resources double, then GDP also doubles. So labor, capital, and human capital grow equally, for instance. Then GDP will increase as fast as the population. So what's going to happen to the GDP per capita if GDP and population increase at the same rate? GDP per capita stays constant. So that's going to be a constant or the same level of standard of living. So the question is, are we going to have sustained growth of per capita income? Sustained growth of per capita income is not going to occur because of any of these three items, any of these three sources of growth. Okay, in none of these cases we get sustained growth of GDP per capita. Okay, so that's not going to happen. But we're going to see next that there is a possibility for it. Write down your notes first and then we proceed. What we learned in the last slide was that growth due to more factor inputs, which are resources, labor, physical capital, and human capital, cannot be sustained. Okay, because of those two properties that we have, the diminishing returns and the constant returns. But if there is technological growth, then GDP is going to increase not at a diminishing rate. Now, assuming same population, ceteris paribus, what it means is that the GDP per capita is going to increase, not at a diminishing rate. So that could be sustained economic growth. All right. Now, the question is what brings about technological change? How can we bring it about? So one thing, technology is really implicit, it's embedded in pretty much everything. Technology is our overall state of knowledge. It's our discoveries, it's our theories. It's somewhat similar to human capital, but not exactly the same. Human capital is about individuals. Technology is about the overall, the social state, the collective state of our knowledge, not our specific workers. All right. So it's not about each worker's quality and level, but the technology is embedded in our physical and human capital. So it's something overall. So there is some similarity and some connection between technology and physical and human capital. It's embodied and embedded in physical and human capital. That's why with investment you can foster it. So growth is a result of investment in capital, both physical and human. And this idea of productivity or efficiency, let's emphasize it one more time because it is important. It's output per unit of input. It's really the rate or speed of production. If it takes fewer resources to produce the same amount of output, then we are more efficient, okay? And our resources are more productive. That's what it means to be productive. That's what it means to be efficient. All right, so this idea of output per unit of input is important. You might want to highlight it or underline it. And also the idea of rate or speed of production. So write that down. There is this concept of the government's budget, and the government's budget is basically its revenue minus its expenses. So the government's budget would be T minus G, where T is tax revenue and G is the purchases of the government. If the government's tax revenue is more than its spending, that's called a budget surplus, which means a positive balance. If the government's taxes are less than its spending, that would be a budget deficit, which would be a negative balance. So in the first case, the government is saving, and in the second case, the government is borrowing. All right. So the government's budget or the government saving could be either positive or negative, depending on whether the government spends more than or less than its revenue. All right. That government's budget balance is called public saving. All right. So this word public, it's the same as government or governmental. So whenever we say public saving, we're talking about the government saving. So write this down. It's going to be very useful as we move on. An important element of growth is saving. So we're going to talk about private saving. If you remember, we had something called the disposable income, which was income after taxes, which is used for either consumption or saving. So we have these two formulas for disposable income, and we can set them equal. So C plus S equals Y minus T, right? And we can isolate for S by moving the C to the other side, so you get Y minus T minus C. That's private saving, okay? So what we can have now is something called national saving. National saving means total saving, and that would be private saving plus public saving. Remember, again, public means governmental, private means non-governmental. So if you add up those two, you're going to get the total saving taking place in the economy. So think of private and public, kind of like private school and public school, or private and public courier service. right? So this picture is from the States, where the first box, the blue one, is the US Post, governmental, and the other ones like FedEx and UPS and whatever are private courier service. So national saving would be y minus d minus c plus t minus g, and you can simplify, so you can cross out the t, so you get y minus c minus g. And S is the total amount of funds available for borrowing. It is the supply of loanable funds. All right, so that's a useful formula. Underline it or highlight it as you write it down. Okay, so again, at the center of the whole concept of growth is this idea of investment in capital. So we really care about that. So we're going to look at loanable funds. The demand for loans is by borrowers, and the main borrowers are firms who borrow funds to invest in their business. Okay, so investment capital I is really the same as the demand for loanable funds. So loanable funds means all loans available, all funds available for borrowing. So we're going to have a market called the loanable funds market. And just like any other market, you have quantity and price and the two axes. So we're going to have the quantity for funds or quantity for loans. And for the price, you have to be a little bit careful. In this case, the price of borrowing is interest rate. The interest rate is the opportunity cost of borrowing. When you borrow money, you have to pay interest. So we are going to have the interest rate as the price of loans. So the demand for loans is the same as investment. So I here stands for investment. And notice that it's downward sloping, because if the interest rate is higher, the borrowers are not going to be interested in borrowing. The supply would be the national savings, which is the total amount of savings available. And we have the equilibrium, okay, just like any other market. So that's going to be the equilibrium interest rate. And the equilibrium level of saving, which is the same as the equilibrium level of borrowing or investment. Now, if the national savings go up, if people save more, or if the government saves more, just like any other supply and demand diagram, you're going to shift it to the right. So you draw a new national savings curve, NS2, to the right of the old one, and you get a new equilibrium. In this case, the interest rate drops and the level of investment increases. Just compare the first equilibrium to the second one. So the interest rate goes down, which encourages more investment. That's why the investment goes up. By the way, investment is the same as borrowing. Okay, that's a very useful information. Keep in mind, in economics, that's what we mean by investment. All right, let's look at if the demand goes up. So demand for funds is the same as investment I. Again, you draw a line to the right of the old line, I2, and you get a new equilibrium. In this case, the interest rate goes up, and the investment, as we said, also goes up. So the interest rate goes up, which encourages more saving, and more saving is going to be associated with more loans available for borrowing. Either way, whether NS goes up or I goes up, the level of investment goes up, which means more physical and human capital, which means more technological improvement in the long run, which means higher long-run growth rate of GDP. Okay, and that is going to result in higher standard of living, right? Remember, we are caring about the standard of living, the comfort of life, right? So one lesson here is that saving equals investment. All right, that's a very useful point. Whatever households save is going to turn into investment. Another useful piece of information is that loanable funds are the same as financial capital. These are two terms that you might see. The book uses financial capital. Some other books call loanable funds. Both are used, they're interchangeable. So if you see the financial capital market, the financial capital market is exactly the same as the loanable funds market that you see right now in the screen. So take a few minutes, write down everything on the screen. Also, draw two diagrams for yourself. So one of them should be an increase in the national savings, and the other one should be an increase in the investment. Also, keep in mind that the interest rate, the small I, is different from investment, which is the capital I. Okay, so don't mix them. The loanable funds market is simply the interaction of demanders and suppliers of loans. Any market means an interaction of buyers and sellers. All right. So that's why we have investment representing borrowers and national saving representing lenders. Now, suppose a higher interest rate than the equilibrium. So I2 is greater than the equilibrium interest rate. You want to see what's going on if the interest rate is high. Just think about the logic first. Interest rate is the price of borrowing. Yeah? If the price of anything is high, are there going to be many buyers or few buyers? If the price of something is high, there's going to be few buyers, but there's going to be a lot of sellers, right? So this is basically old stuff you've seen before. You draw a horizontal line at I2, and you're going to see the intersection of that on the demand, in this case investment, and that's going to give you QD, which is quantity demanded. It's fairly small compared to quantity supplied, which is much larger. So at I2 greater than the equilibrium, there is excess supply of funds, which is called a surplus. But there's not many people who want to borrow at this rate because the rate is just too much. There's a high interest cost for borrowing. That distance is the surplus of funds. Okay, so this is a simple demand and supply diagram with the surplus, which is the distance between quantity supplied and quantity demanded. Suppliers of funds have to lower the interest rate to attract more buyers, right? So they have all these funds and nobody's there to borrow. It's going to have downward pressure on the price, in this case the interest rate. So the interest rate drops to the equilibrium level. All right, so we're going to move gradually toward the equilibrium. Now let's look at the opposite case. Let's say the interest rate is low. Again, just pause for a moment and think of the logic. If the price of anything is low, there is incentive. There's going to be more incentive for the buyers, in this case the borrowers, to borrow, but the sellers, the savers in this case, won't have much incentive. Right? So you draw a horizontal line, you find the quantity supplied, quantity demanded, and it's clear that there's excess demand for funds, which is a shortage. And you can show that graphically, the distance between QD and QS. Whenever there's a shortage of anything, what's going to happen to its price? Yeah. Some demanders can't borrow at this rate, so they're going to bid for a higher interest rate to get the loan. Imagine if you want to get a loan and you're really desperate, then you will have to offer a higher interest rate. So the interest rate increases to the equilibrium level, right? So we go back to the equilibrium. Wherever you start, whether it's lower or higher, you just go back to the equilibrium. It's all good. All right, so this is really just a good old market mechanism. Pause here and write down and draw your graph. The neoclassical growth model has certain properties that we talked about. Now, this is an alternative, basically, knowledge-driven growth. So the diminishing marginal returns that we looked at is based on physical goods and inputs. So a machine or factory, which is a physical good, can be used by a limited number of workers. You can have only one worker on a computer, for instance. Each additional worker will add less to the output than the previous worker. This is the meaning of diminishing returns because of limited space. So it's kind of like there is some form of competition. There's rivalry. Either you get it or the other person, right? There's limited space. But if it comes to ideas, if it comes to knowledge, then you don't have diminishing returns anymore. Knowledge can be used by several people at once. If you have a formula, if you have the knowledge of programming, you have a bunch of people sharing. You can have a bunch of people using the idea. It's not physical. So in that case, you could have increasing marginal returns. So this is kind of like a rival, a newer theory of growth. Sometimes a negative shock can actually be beneficial. For instance, think of an oil shock. Oil shock means when the price of oil goes up. Whenever you have prices, you have to think about incentives involved. This is going to create an incentive to develop technologies to discover and extract more oil. It's gonna give incentive to develop more fuel efficient products because the oil is more expensive, so let's look for a way of using that more efficiently. And it's going to create incentive to develop alternative inputs that are more efficient, right? So it's going to create a lot of incentives about coming up with creative ways of saving on costs, basically. Wow, that's cool. This could be a solution to resource depletion and environmental degradation, right? It's going to give us incentive to innovate. It's going to give us incentive to develop R&D, research and development, right? So here's the thing. Think of oil. Based on our technology, we can extract about 30% of the oil in a reservoir. The rest, 70%, remains under the earth, right? So the idea that we're going to run out of oil, well, we're not really running out of oil. It's already there. It's just a matter of developing the technology to extract it. And right now, we can extract a lot more than 30, 40 years ago. So the idea is that because of these price signals, a lot of these environmental and resource problems could potentially be solved, since it gives us incentives to develop other possibilities. All right, pause here and write down.